Hi, I'm Jake.
I'm Mike.
And welcome to another episode of Problem Solved. What's the topic for today?
Understanding encoder offsets.
All right, let's do this. So Mike, tell us a little bit about the setup here, starting with the hardware and then the software.
We've got a high pole servo motor here. This would be often used in elevator applications. We've got our F6 VFD connected to the motor, and then connected to the drive, we've got our CombiVis 6 software.
Next, I'm wondering about what encoder offset is. Can you explain that a little more?
Yep, so very basically the encoder offset is the position of how the encoder is mounted relative to the windings of the motor. And that position is required for the drive to know in order for it to control the speed and torque of the motor properly.
Now, how would you go about understanding the encoder offset and maybe remedying any issues that might occur?
It does have to stay constant, so one common reason it comes up is because the encoder is slipping on the motor shaft, so that would have to be addressed first. But otherwise, in general, on the first time you run the motor, you're going to have to know or learn the offset before you can spin the motor. But then as long as the encoder is mounted properly to the encoder, you're good to go and you can run for the lifetime of the motor.
Now that we got an overview of what encoder offset is, why don't you show us how to go about doing an encoder learn if that's something that's needed?
Sounds good. So we'll do that with our CombiVis 6 software over here. First things first, you'll just need to open up your CombiVis 6 software and make sure you're connected to your drive. You can use the device scan wizard here to find your drive, but we've already done so, and we have the drive online here, which you can see with the green plug. And then you can get into learning the encoder offset. So within the CombiVis software, there's 3 easy ways to learn the encoder offset. The first and most basic doesn't actually require a learn at all. If you're using a KEB motor, all you have to do is type in the part number here and hit the green box. And all of our motors are produced with a known encoder offset value. So it just pulls in that data from the motor database, and the encoder offset is learned that way. Next up is with the identification wizard. So in that, you are doing a full motor identification, which is pulling the resistance, inductance, back EMF, and so on of the motor. But you can also opt to do the encoder learn that way. So you enter the basic nameplate data, and you just need to make sure that this box is checked for the detection of the encoder mounting position. Then if every criteria is met to run, you just hit the start identification, and it'll go through the full motor identification process. Finally, you can just do the encoder offset manually, and with that you need to use the parameter DD00 and select your learn method. With this one, we'll just do CVV, or constant voltage vector. And then you simply just enable the drive. And you can see the rotor detection is active. You can see the system offset changing up here. And we'll just wait for that to complete. And you'll get this ready status once it's complete. You can disable the drive, turn the detection off so it doesn't do it again the next time you go to run, and your encoder offset is learned. So there you have it. With one of those 3 simple methods, you can learn the encoder offset of your motor, and then you can properly run it for the speed and torque commands that you're giving it.
Thank you, Mike, for taking us through that important topic of encoder offset parameters. If you have any more questions, reach out to us at KEB America.